Okay, guys, welcome to our topic of solving rational equations, and we're going to be on page 139 in our notes packet this time. Okay, so now we're going to try and solve an equation and basically figure out what x equals or whatever our variable is for an equation based on rationals, i.e., fractions that are made of polynomials. Okay, so once again, kind of the biggest thing for these is going to be getting common denominators and making sure that we check for extraneous solutions. Okay, so you may remember extraneous solutions from some of the other topics we've done before, and that just means that your answers can sometimes not be real answers because with a bunch of things squared, a bunch of things being canceled out, sometimes we pick an answer that looks like it's going to be right, but there's a hole there or there's some other issue that causes that answer not to work. Okay, so basically we like to start by listing what our excluded values are or our extraneous solutions. So we know that if we get an answer that is one of those numbers, we'll be able to disregard it and say that that solution does not count as an actual answer. Okay, so let's take a look at number one. Okay, so all of these extraneous solutions are going to come from the bottom of these fractions. All right, so if we take a look, we'll see they all look pretty similar, a little bit different on that second one, but they all look pretty similar. And if we look at the solutions for them, like 5x squared equals 0, and we're basically going to discover that x equals 0 is the solution for all three of those. And this number that I found is what I'm going to call an extraneous solution or an excluded value. And this is the first thing we should do when solving any of these problems is figure out what our excluded values is. So solve for all of the denominators in your problem and figure out what those numbers are. And x is definitely 100% not allowed to be that number. So when I solve this equation, if I get that x equals 0, I'm immediately going to throw my answer out and say that that is an extraneous solution. So now the real question is, how do we solve these? All right, those x's are kind of stuck at the bottom of our fractions, and we're not great at handling that situation. So what we can do is we're going to get all our denominators to match. And lucky for us, these two right here, the first and last one, are already matching. They're already 5x squared. So can I get this middle one to also be 5x squared? Absolutely. Let's multiply by x on top and bottom. And then I'm going to rewrite our problem. Let's see what we've got. 3 over 5x squared equals 3x over 5x squared plus 1 over 5x squared. So here we are. We've kind of rewritten our problem, and now you notice all of these denominators are common. So what am I going to do? I'm going to take this side, I'm going to multiply it by the denominator, and I'm going to take everything on this side and also multiply it by 5x squared. And what's going to happen is you can put some imaginary parentheses. All my denominators are going to cancel out, okay? And this step kind of gets ingrained at some point. Once those denominators are common, we realize we're going to multiply and cancel them out, okay? And I'm left with just this. 3 equals 3x plus 1. And this equation is actually very simple for us to solve. We know how to do that. Minus 1, 2 equals 3x. And when we solve this, you're going to get x equals 2/3. And that's not one of my excluded values, so we can kind of say that is okay and good to go. All right, let's try one more of these. Very similar problem in number 2. Okay, so again, let's start by stating our excluded values. So excluded values and these extraneous solutions always come from the denominator. Okay, so again, if I solve x squared equals 0 or 2x squared equals 0, we're going to get the same solution, x equals 0. And that one is a bad number for me, right? So this is my excluded value. All right, so remember, if we get 0 as an answer, make sure that we throw that one out, okay? Now, the next step is going to be, can we get common denominators? So let's think about what we should multiply to get common denominators. So if we take our problem, x minus 5 over 2x squared minus 1 over x squared equals 6 over x squared. And I already see each of them as x squared. Let's multiply this one by 2 and this one also by 2. And I'm only multiplying by the 2 so that I end up with all three of these as being 2x squared. Okay, so here we go. X minus 5 over 2x squared minus 2 over 2x squared equals 6 times 2, 12 over 2x squared. Okay, great. Now we're at a point where our numbers are all matching on bottom. Our denominators are good to go. So basically, I'm just going to multiply the whole thing by 2x squared. Left and right side. So this is all balanced. These are going to go away. Okay, and I'm left with x minus 5 minus 2 equals 12. Let's combine these two together. And I'm going to end up with x minus 7 is 12. And if I add that 7 to the other side, x equals 19. Okay. And again, let's double check it against our excluded values. So are we good to go? Yes. I said my excluded value was 0, and my number is 19, which is not 0, of course. So let's check that off. Okay. So once you solve, always double check against the excluded values. And that's the very first thing we should always check. Say, hey, what are my excluded values? Then solve. All right, let's do another problem. This time you can see my denominators look a little bit more complicated than they did in the previous problem. You'll notice though, if we factor this, I'm going to start by factoring that one piece that's still quadratic right here. Okay, and minus 4 adding up to 3, so it looks like we've got n plus 4 and n minus 1. Okay, so that piece is now factored out. And if I start getting common denominators, you'll notice I don't actually have to multiply very much. N plus 4, n minus 1. I can take n plus 4 over here, and on the top as well. And I can take n minus 1 to the top and bottom here. Okay, so I'm going to go ahead and distribute these out and see kind of where we end up. So I've got 2n plus 8, and I'm leaving the bottom alone just because we want to just make sure that it's the same. N minus 1. Over here, we multiplied by n minus 1. That was kind of the piece we were missing. N minus 1 over n plus 4, n minus 1. And the last one was already the same, 1 over n plus 4, n minus 1. Great. You'll see now, look, all of our denominators match, and we're ready to go to the next step. Okay, so we've got these matching denominators. Before I cancel or do anything, let's state our excluded values. Okay, so here we go. I've got n plus 4. Let's solve that. N plus 4 equals 0. So, and you should be able to get this as being n does not equal negative 4. And same thing with n minus 1. So we're going to have n minus 1 equal to 0. And move the 1 over, we get n should not equal 1. Okay, so these two numbers right here, my excluded values. So basically, we should not get one of those as our answer. If we do, we know that that solution is invalid and we're going to throw it out. Okay. Next step, let's go ahead and cancel our denominators. Okay. If you're feeling comfortable at this point, go ahead, try to solve the problem and see where you end up. Okay. So I'm going to multiply my whole equation, right? Left and right side by that denominator, which reads as n plus 4, n minus 1. And of course, it's going to do the same thing it's been doing. It's going to cancel out all of these pieces at the bottom. And I'm going to be left with the equation that I had at the top. 2n plus 8 equals n minus 1 plus 1. And let's kind of see where this ends up resolving. I'm going to cancel these ones out. Minus 1 plus 1 go away. And then I can subtract this 2n over. So 8 equals negative n. And basically that turns into n equals negative 8. So tell me something. This answer, is it valid or not? Well, it's not one of my extraneous solutions, so I'm going to say that is okay. And the answer ends up being n equals -8. Okay, having seen the last problem, see if you can solve this problem entirely on your own, and then feel free to compare against my work and see how you did. The first thing I'm going to do with this problem is I'm going to start with these two denominators, and I'm going to go ahead and factor them. And they're both the same, so luckily for us, it's going to factor perfectly. So -12, I'm going to break this into -6 and +2, n minus 6, n plus 2. Okay, same here. These are both going to be n minus 6, n plus 2. So let's see what our equation looks like right now. 3 over n plus 2 minus 5 over n minus 6, n plus 2 equals 1 over n minus 6, n plus 2. Okay, with this written out, let's go ahead and find those excluded values. So I see two different terms here, n minus 6. So let's do n minus 6 equal to 0 and get n equals 6. Let's do n plus 2 equal to 0 and get n equals -2. Now these are my excluded values, of course, so I'll say don't equal those numbers. So these are my excluded values. All right, so remember that means my answer should not equal 6 or -2. Let's go ahead and keep moving along with this. Let's get our common denominator. So I'm going to take this, and I see n plus 2 in each of these. That's good. Let's take n minus 6 and bring it to this one. N minus 6, n minus 6. All right. And I'll go ahead and distribute this 3 in. So we've got 3n minus 18 over n plus 2, n minus 6. It's 5 over n minus 6, n plus 2 equals 1 over n minus 6, n plus 2. All right, awesome. I'm going to go ahead and say let's multiply these denominators away, get rid of our fraction, and then we'll be good to go. So these are going to cancel out all three of these, and then we're going to be left with this equation. We've got 3n minus 18 minus 5 equals 1. And we can go ahead and start getting this together. 3n minus 23 equals 1. 3n equals 24, and n is going to equal 8 as my final solution here. Okay, so is this one of my excluded values? Let's check. Doesn't look like 8 is in my list, so this answer looks good to me. So if we look at number 10, you'll see, hey, this seems pretty familiar. It looks just like what we've been doing previously. And even there's not really any factoring for us to do to make this complicated. So let's start by just trying to figure out what our excluded values are. So I see k and k squared, and those are both just going to give me the same excluded value. K equals 0 and k squared equals 0. Both of these just lead me to say, hey, k equals 0. And that is not a good value, so let's just remember to exclude that from our answer list. So remember, 0 is not a good answer. Let's see how this one works out. So first thing we know to get common denominators. So let's multiply everything to get those common. So k plus 2 over k plus 6 over k squared equals 5 over k squared. And you know that I'm going to try and get all of these to match. So I see some k squareds. Let's make this one a square by adding an extra k on there. So there we go. We're going to distribute the top part, and we're going to leave the bottom together. So k squared plus 2 over k squared, sorry, plus 2k, plus 6 over k squared equals 5 over k squared. Let's take the next bit and cancel the denominators out, so let's multiply the whole thing by k squared, canceling all of these guys out. And now I've got k squared plus 2k plus 6 equals 5. Uh-oh. This looks a little weird, doesn't it? But guess what? You already know how to solve equations like this. Let's subtract the 5 back to this side, and you're going to see k squared plus 2k plus 1 equals 0. And this is a quadratic. So we can either factor or use quadratic formula. So in this case, this one factors pretty easily actually, because 1 times 1 is 1 and adds up to 2. So I'm going to factor this and get k plus 1 times k plus 1 equals 0. And my solution for this is going to end up being k equals -1. And we should of course check if this answer is valid. So let's go back to our excluded value list and make sure it's not on the naughty list. I see my excluded value is 0. This answer is not 0, so we're good to go. And we just double checked our work. So you can see this problem was kind of interesting. We got this quadratic after we canceled all our denominators, and that led us to have to use some advanced solving techniques like factoring and quadratic formula. So you do know both of those techniques. You could use either one as long as it gets you to the result that you want. Okay guys, here's one last problem on the page. Let's see how you do. Make sure you try this yourself and then check your work against mine. So you can see the very first step I took, I went ahead and got that excluded value. And I said, oh yeah, the 6m, that's going to be the piece that I can really calculate an excluded value for, and got 0. Now notice, this one's just a 1 over 6. That doesn't really give me an excluded value because there's no m in there. Now I've set up my equation, and I'm going to go ahead and get common denominators by multiplying that last piece by m on top and bottom. So all my denominators will now be the same, which is 6m. So now I've got this m squared minus 2m minus 3 for 6m equals 1 over 6m plus m over 6m. Now what should I do next? Take a second and do the next step if you know what to do. So you can see I went ahead and canceled everything out, and then we got a quadratic, so let's get everything to one side. Minus m minus 1 minus m minus 1 m squared minus 3m minus 4 equals 0. We can again just factor this or use quadratic formula, however you want to do it. But I'll factor, and we're going to get m minus 4 and m plus 1. And this is actually going to give me two different solutions. We're going to get m equals 4 and m equals -1. Let's make sure we double check both of our answers to make sure they're not on the naughty list. Right, come up here. Oh yeah, my excluded value was 0. And 4 and 1 are definitely not 0. So these both seem fine. Okay, so I got two different answers, m equals 4 and m equals -1. Okay guys, that wraps up our lesson on solving rational equations. Hopefully you found this helpful, and good luck with studying.